Across the vast expanse of the cosmos, a breathtaking spectacle unfolds, the birth of stars. This process, both ancient and ongoing, is a testament to the dynamic and ever-changing nature of the universe. These celestial fireballs, scattered like diamonds across the night sky, don't simply pop into existence. They are the result of complex and intricate processes that span millions of years. They are forged in the hearts of enormous cold clouds of gas and dust, known as molecular clouds. These clouds, often spanning light years across, are the cradles of star formation. These cosmic nurseries are the birthplace of stars, the fundamental building blocks of galaxies and the universe as we know it. Within these clouds, the seeds of stars are sown, waiting for the right conditions to ignite. Imagine, if you will, a cloud so vast it dwarfs our solar system. These clouds are not static, they are dynamic, constantly shifting and changing as they interact with their surroundings. This cloud is not like the fluffy white ones we see on Earth. Instead, it's a dark and frigid place, filled with molecules like hydrogen and helium, along with traces of heavier elements. The temperatures within these clouds can drop to just a few degrees above absolute zero. Instead, it's a dark and frigid place, filled with molecules like hydrogen and helium, along with traces of heavier elements. These elements, though sparse, play a crucial role in the formation of stars, acting as the building blocks for the complex chemistry that occurs within these clouds. These are the very ingredients from which stars are made. Over time, these clouds can become unstable, often triggered by external forces such as shock waves from nearby supernovae or the gravitational influence of passing stars. Within these cosmic clouds, a story billions of years in the making is about to begin. As regions within the cloud collapse under their own gravity, they form dense cores that will eventually become stars. The birth of a star is a remarkable process, driven by the relentless force of gravity. As the core collapses, it heats up and the pressure increases, leading to the formation of a protostar. It's a delicate dance between opposing forces where gravity pulls matter inward, compressing and heating it, while other forces try to resist this collapse. The balance between these forces determines whether a star will form or if the cloud will dissipate. Understanding this process allows us to peer back in time, to witness the formation of the very first stars that illuminated the universe after the Big Bang. These first stars, known as Population 3 stars, were massive and short-lived, but they played a crucial role in shaping the early universe. It's a tale of cosmic proportions, full of wonder, beauty, and the endless cycle of creation and destruction that defines the universe we inhabit. From the birth of stars in molecular clouds to their eventual demise in supernovae, the life cycle of stars is a fundamental aspect of the cosmos. When a star reaches the end of its life, it can explode in a spectacular supernova, scattering its enriched elements into space. These elements then become part of new molecular clouds, continuing the cycle of star formation. In galaxies across the universe, this cycle of star birth and death continues, driving the evolution of galaxies and the cosmos itself. Each new generation of stars builds upon the legacy of those that came before, enriching the universe with heavier elements and complex structures. Star clusters, where many stars form together, provide a glimpse into the early stages of star formation. These clusters can contain hundreds or even thousands of stars, all born from the same molecular cloud. Observing these regions in distant galaxies helps astronomers understand the processes that govern star formation and the evolution of galaxies over cosmic time. With the help of powerful telescopes and advanced technology, we continue to uncover the mysteries of star formation, piecing together the story of our universe, one star at a time. As we gaze up at the night sky, we are reminded of the incredible journey that each star has taken, from a cold, dark cloud to a brilliant beacon of light. The story of where stars begin is a story of the universe itself, a testament to the beauty and complexity of the cosmos. Within the cold, dark depths of a molecular cloud, gravity reigns supreme. These clouds, often spanning light years across, are the birthplaces of stars and planets. They are composed primarily of hydrogen molecules, along with traces of other elements and dust particles. Despite their vastness, they are incredibly cold, with temperatures just a few degrees above absolute zero. These clouds, though seemingly serene, are in a constant state of motion, with particles drifting and swirling in a cosmic danceout. The interplay of gravity and turbulence within the cloud creates a dynamic environment where matter is continuously moving and interacting. Their particles are pulled and tugged by the invisible hand of gravity, which acts as a sculptor shaping the cloud structure over time. Gravity's influence is subtle but persistent, gradually drawing particles closer together. Over eons, these subtle tugs can have dramatic consequences. The cloud's structure evolves, with regions of higher density beginning to form. These denser regions are the seeds of future stars, where the gravitational pull becomes strong enough to overcome the internal pressure of the gas. As more and more matter clumps together, the gravitational pull intensifies, drawing in even more gas and dust. This process is akin to a feedback loop where the growing mass attracts additional material, further increasing its gravitational influence. Imagine a snowball rolling down a hill, gathering more snow as it goes, growing larger and larger. This analogy helps us understand how a small initial clump of matter can grow into a massive object capable of forming a star. Similarly, dense pockets within a molecular cloud act as seeds for star formation. These pockets, or cores, are where the conditions are just right for gravity to take over and initiate the collapse process. As these pockets grow denser, they begin to collapse under their own weight. The collapse is driven by the relentless pull of gravity, which compresses the gas and dust into an ever smaller volume. The collapse starts slowly at first, but like the snowball, it accelerates over time, eventually reaching a critical threshold. At this point, the core's density and temperature rise rapidly, setting the stage for the birth of a new star. This collapse is not uniform. Different regions within the cloud experience varying rates of collapse, influenced by local conditions such as density, temperature, and magnetic fields. Instead, it happens in fits and starts, with different regions collapsing at different rates. This uneven collapse leads to a complex and fragmented structure within the cloud. This uneven collapse leads to fragmentation, breaking the cloud into smaller and smaller clumps, each of which can become a separate star-forming region. These fragments are the building blocks of future star systems. Each clump is destined to become a star or a system of stars. The process of fragmentation ensures that a single molecular cloud can give rise to multiple stars, often forming clusters that remain gravitationally bound. This is how a single molecular cloud, vast beyond human comprehension, can give birth to an entire cluster of stars, each with its own unique characteristics and potential for hosting planets. All bound together by gravity, these star clusters can remain intact for millions or even billions of years, serving as cosmic nurseries where new stars continue to form and evolve. As the molecular cloud collapses, it doesn't simply shrink into a single massive object. Instead, it undergoes a fascinating process that leads to the birth of new stars. Instead, it fragments, breaking apart into smaller and smaller clumps. These clumps are the seeds of future stars, each one a potential birthplace for a new celestial body. This fragmentation is driven by the complex interplay of gravity, turbulence, and magnetic fields within the cloud. Gravity pulls the material together, while turbulence and magnetic fields create resistance, leading to the formation of distinct fragments. Think of it like dividing dough into smaller pieces before baking. Each piece of dough represents a fragment of the molecular cloud, each with the potential to become a star. Each fragment, now a distinct entity, continues to collapse under its own gravity. This collapse is a critical step in the formation of a star, as it leads to the concentration of material at the core of the fragment. As it collapses, the material at the center of the fragment begins to heat up. This heating is a result of the increasing pressure and density at the core, which causes the temperature to rise. This happens because the gravitational energy of the infalling material is converted into thermal energy, raising the temperature at the core. The core becomes hotter and denser, setting the stage for the next phase of star formation. This hot, dense core is the nascent stage of a star known as a protostar. A protostar is the earliest stage in the life of a star, a time when it is still gathering material and growing in mass. Protostars are not yet true stars. They are in a transitional phase, still accumulating mass and not yet hot enough to initiate nuclear fusion, the process that powers stars. They are still shrouded in a thick cocoon of gas and dust which continues to rain down onto the central core, further increasing its mass and temperature. This cocoon acts as a protective layer, shielding the protostar from external influences. This infalling material forms a spinning disk around the protostar, a structure that will eventually give rise to planets and other celestial bodies. The disk is a crucial component in the star formation process, as it helps to channel material onto the growing protostar. The protostar, hidden from view, continues to evolve, its fate intertwined with the ongoing processes of accretion and heating. Over time, the protostar will gather enough mass and heat to ignite nuclear fusion, marking its transition into a true star. The journey from a collapsing molecular cloud to a fully formed star is a complex and lengthy process, taking millions of years. Each stage is marked by significant changes in the physical and chemical properties of the material involved. Star nurseries, regions within galaxies where star formation is actively occurring, are filled with dense molecular clouds. These clouds are the birthplaces of stars, where the conditions are just right for the process of fragmentation and collapse to begin. Observing star formation is a challenging task, as protostars are often hidden within their cocoons of gas and dust. However, with the help of advanced telescopes and space observatories, astronomers can peer into these regions and study the early stages of star birth. Infrared observations are particularly useful in this regard, as they can detect the heat emitted by protostars, even when they are obscured by dust. This allows scientists to gain valuable insights into the processes occurring within these hidden regions. The fragments of molecular clouds that collapse to form protostars are the building blocks of future stars and star systems. Each fragment holds the potential to become a new star, with its own unique characteristics and properties. The formation of stars is a fundamental aspect of cosmic evolution, shaping the structure and development of the universe. As stars form and evolve, they influence their surroundings, contributing to the ongoing cycle of matter and energy in the cosmos. In summary, the process of star formation begins with the collapse and fragmentation of molecular clouds. Through the interplay of gravity, turbulence, and magnetic fields, these fragments evolve into protostars, which continue to gather mass and heat until they ignite nuclear fusion and become true stars. The journey from a molecular cloud to a shining star is a testament to the incredible processes at work in the universe. It is a story of transformation, growth, and the birth of new light in the cosmos. As we gaze up at the night sky, we are witnessing the culmination of these processes, the end result of countless molecular clouds collapsing and giving birth to the stars that light up our universe. Understanding the birth of stars not only deepens our appreciation of the cosmos, but also highlights the intricate and beautiful mechanisms that govern the universe. Thank you for joining us on this journey through the birth of protostars.
Like and subscribe to start your journey today.